Started. Today is the 7th of May 2024, and this morning there was rain and very cloudy sky of heavy rain that uh, seemed to be the first heavy rain that we had rain for over a month, and farmers have some problem because they have no water for plants, trees, and some products of fruits. Well, today's topics I'm going to talk about the course that I offer for senior student in electronics engineering. Senior have two students. The course is the Microelectronics Manufacturing. I will talk about the details of the course. Let's get back about the course that I have been offering in the second semester. That's when I study a master degree in microelectronic processing at the Rochester Institute of Technology, Rochester, New York. Let's look back at the power. I've been here for 25 years at KMITL Electronic Department, and look back another 5 years ago. So when I graduated, that's 30 years ago. The program is very intense. I also need to attend the quarter system. That means for 1 year they have full semesters. Actually, not semester, full quarters. Yeah. We have a fall, we have spring, we have winter, and summer. So that's why each quarter is going to be very short compared to the semester system. I had to attend classes mostly about semiconductor devices, and you need to learn about how to process your microelectronic processing that you have to go through about sorry about the noise there on construction in the building. You have to go through many courses that you need to sit in class, and you need to also get in the clean room to do the real thing, just like you're working in the factories. But you learn a lot. And the one thing is that Professor Dr. Lynn Fuller, the head of the department, he used to work for Motorola, and then he also introduced the Six Sigma program. As I mentioned earlier about our Six Sigma program, it's just very simple, and they use this program worldwide. And the main point is that they want to improve yields. So any organizations, any industries, they need a better yield, and that close to 100%. So that means you have no defect. We don't want have so many defects from production lines. And then I think that's going to be very useful, for students in Thailand to be familiar with Six Sigma concepts. And the The concept is that you just use very simple equations, use the basic math that you're familiar, you know. You just collect data from production lines, and then you use mean and also standard deviation to analyze your data, what if you pass the Six Sigma program or not, or you have a better yield or not from the process. And you have, if it's not good enough, you need to go back to your process lines and improve or correct, whatever, mistake, both hardware and software. But for the course, I just ask students to analyze, data, not do the process and then take down our data. And that's going to take more time. But over there, they have complete machines, instruments to collect data in a clean room. So that's course took about 1.5 to 2 years, but you just should be ready to go to work in industry. About the course, that's related to parameters in the term of semiconductor processes. For example, you need to grow oxide, and you need to measure the thickness of silicon dioxide, right? For example, the gate oxide of NMOS or PMOS or CMOS. Also, you need to do sputtering. You need to do doping, N-type, P-type. You need to do the drive-in. Of course, N-type and P-type, you want to change electrical properties of materials of our semiconductor, right? So the transistor can be on and off, and you know that the transistor is just working like electrical switch. This is apply voltage to the gate, and then you can turn on and off transistor. And also you need to do the contact, metal contact for the input and the output. For external communications, right? You need that to connect outer components. And also you need to do photolithography. You need to do work on the process in the term of you need to start from wafer. That's the just silicon, and then you need to do N-type and P-type. So what you need to do is you need to take the wafer, get into the furnace. This is just for example, to grow silicon dioxide. So you need to drive into the furnace, but before you start, drive in the wafer into the furnace, you need to set up the furnace just to be the right temperature and no fluctuation of temperature, right? Sometimes temperatures drop or temperature rise, get higher or lower. You need that as stable as possible. So sometimes it takes like 2 hours, and you need to log in the computer. You need to type in the data, what is the voltage that you set up, and what is the target of silicon dioxide thickness that you are looking for. And by the end of the process, you need also to take down the data, type in the computer what the silicon dioxide thickness that you already have, and then you need to so some students come to work on that furnace later on. You need to use your information that you log in your computer. So for silicon dioxide growth, you also need to do wet silicon dioxide growth and dry. Wet is mean in the term of you need to apply also the vapor, the water vapor, H2O, with the combination of oxygen. So that's a long process. This is just only one sample of the process to do microelectronic processing. And then for this course, I also talk about reliability. You need to do the accelerate testing. For example, you do temperature acceleration. That means you're working on the higher temperature or lower temperature. By applying Arrhenius equation, you can look for the activation energy. And also you need to use math to analyze the data. We're talking about the cycle time that when do you do the process. For example, you have 1,000 wafers, and then one wafer you need to go through 70 processes to make a CMOS or NMOS or CMOS or PMOS. And then you need to see that the factory have ability to run the process, in time or not. It's going to be, can be overload or underload. Underload is mean that you still have ability, to run the processes. You have enough time, let's say, just for a simple one. But if overloaded, that means you cannot finish the job in time. And you need to also be able to calculate the cycle time CT. That's in the term of yield, in the term of work in progress, in the term of turns per day, and also the number of processes that you need to run to go through to complete your CMOS or NMOS or PMOS. That's the cycle time. And also you need to do scheduling. You need to do cost of ownership. You're talking about a fixed cost. You need to talk about variable cost that are just like when you're working in an industry. You need to calculate for the cost of the factory. Of course, when you do something, when you do some products, you need profits, right? And then you need to do the calculation for the cost of ownership. That's another topic of this course. And what else? You also need to be able to calculate the failure rate. For example, when you start working on a system, electronic system, they have many components. You have so many devices, and you might want to focus on some type of components. For example, transistor. And you keep running the system, and then you want to see how many components fails. and how long it take. So you take that information to calculate for the failure rate in the term of FIT. That's the failure in time. It might not, it might be difficult for you to understand if you do not working in this area. But I just talk about what's going on with the course, and this is actually the real thing that you're working in industry of semiconductor industry. Yeah, that's about the course, but the main topic again is going to be about the Six Sigma program. You need to calculate CP, the process capability. You need to calculate for CPK, the potential capability. You need to calculate for the mean, and then you want to see if your data is out of our limit or not, in the term of you set up a low level limit, low scale limit, LSL and USL. That's the upper scale limit. You don't want your data, out of the limit, or in the term of TAIL, TAIL or FF. That's become a defect, and you need to improve your process capability, or to make it better to have the final product. And here, and for the course, in terms of when I study, it's become an interdiscipline background that you need to apply both mechanics, electronics, physics, chemistry. So that's why I say it's become an interdiscipline. Okay, that's all for now today.